Hello, my name is Mikhail Goubko. I'm a leading researcher in the Institute of Control Sciences in Moscow. Our institute is the biggest and the oldest research organization in Russia in the field of control theory and its applications. I'm also the deputy director of this institute, which was supposed to host a part of this year's Congress, and I believe will host the next year Congress together with the Institute of Philosophy. I'd like to introduce the section of cybernetics and control science, and I want to explain my personal interest in the future Congress and to introduce my view of our section. First, I'd like to say several words about my research area, not because it is relevant to the topic of the Congress, but because I think that my research interests to some extent typical and can be a good introduction to our field. And they will explain the point of view of control theories on the system science. I deal with the problems of system structure optimization. There are several perspectives to view at these problems. First, from the point of view of applications, the problems of structure optimization arise in almost any area of science, engineering, and management. For instance, in information technologies and communications, it is the problem of communication network topology design. In urban study, we have a similar problem of road network topology design. In material science, we seek for a material and, in fact, for a molecular structure with prescribed physical and chemical properties. In management, the problem of optimal organization structure also belongs to this class. In human-computer interaction, many problems of user interface organization can also be reduced to the search of an optimal taxonomy of items that represent different functions of an information system. So, there's a long list of applications, but I will stop here and come to the next perspective, which is a control science perspective. In control science, we have a control subject and a control object. And the subject can apply control to different aspects of the object. When the control affects the structure of the system, we have the decision-making problem of the system structure design. From the mathematical perspective, these problems belong to the fields of graph theory and combinatorial optimization. To develop efficient algorithms for optimal structure search, we employ different areas of mathematics and computer science. So, this is an interdisciplinary field, even from the point of view of mathematical methods and tools. From the system science perspective, we can pose a question whether structures of systems of different nature have something in common, and is there any general law of optimal system structure design? If someone asked me about these general laws, I'd answer, I don't know. Because we see the general patterns in structuring the system of different nature. But we cannot be sure that they are an objective reality, and they're not just the fruit of our cognition, the reflection of our lazy mind that seeks to find familiar patterns even if they do not present in reality. So a practical and engineering answer to the question about the general law is that we can talk about convenient formal mathematical models that are usable because they are applicable and help to solve applied problems. Many examples of such general models come from the network science, with its desire to focus on the system structure and to remove all other details of system being, treating them as irrelevant. So, to sum up, we apply combinatorial optimization and graph theory to solve applied problems of system structure design, reducing them to several general formal models from system science. Now I pass to the next point, the main idea of our section. The control theory is an engineering theory. Since its appearance, it concentrated on automation and remote control in complex technical systems, like missiles and aircrafts. However, evolving through decades, Control science became the general theory with diverse applications that include cyberphysical systems, economic and social systems. Many of my colleagues claim that control theory now can explain the whole world. However, I know that these universal theories they produce often seem naive and ill-founded to professional philosophers and cybernetists. Therefore, I see that a wider view is required to evaluate these theories and to position them against the broader context of general theories of this kind. From the other side, transformation into formal models and implementation of mathematical methods is a natural direction of development of any theory. And I believe that control theory can give a concise and comprehensive language for people from cybernetic science, for philosophers, social scientists, psychologists, and cognitive scientists. The idea of our section is that it should be an integration point for the control science community, the community of mathematicians and engineers on the one side, and for the cybernetics community on the other side. Thank you.